Hello students, in this video, in the continuation of the iteration construct, we are going to perform another very important question in which we will learn the concept of counting the value. Means if we want to count something, then how it can be done. Again, it is a very important basic concept which require in complex programming, means counting the terms. For example, you want to count even number, you want to count odd number, you want to count prime number, means counting. The concept behind this concept is how we can count anything. So let's begin with the question. In this question, it is asked, count the numbers divisible by 5 in the range of two given numbers, say A and B, where A is less than equal to B. So in this question, first we have to read two numbers A and B so that we can count the number in the range of A and B. So let's start. First, I am reading a variable A, another number in B. Both are the integer value, that's why I am writing int. Input, enter start value, int, input, enter end value. So here A and B are the starting and ending point. So we have read A and B. Now we have to write the loop from A to B. So I am initializing the loop index with A. So here I have taken, let us say I. It is initialized with A. We have to continue the loop while I is less than equal to B. Now I have to count the number which are divisible by 5. So first we need to check whether this is I. It is continuing from 1A to B. So I need to check when the value of I is divisible by 5. To check this, we need to write if condition. If I mod 5 equal to 0. So in this way you can check the condition. And now here in the if condition I have to perform the work of counting. So how we can count the things? We can count means a counter. Counter means a place or a variable where you keep the initial value and you continue it by incrementing the value by 1. Because suppose if I ask you to count 1 to 10, then how you will do this? You count 1, 2, 3, 4, 5 in this way. So what happened? You are initializing a memory. Memory means variable. Let us say X. You are initializing a memory with 0. This is the counter variable. Counter variable means it could be any variable which is having the initial value 0. So, as I have told you, if I told you to count from 1 to 100, so you are doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are initializing the counter variable as 0. As soon as this condition is satisfied, the counter variable will be incremented by 1. Means when this condition is true, it will become 1. And whenever again this condition is true, it will become 2. Likewise, means whenever this condition is true, this value will be incremented by 1. Technically, we call such type of variable for which the initial value is 0 and we are incrementing the value by 1 as a counter variable. So remember that whenever it is asked to count something, to count something, you have to take a counter variable. Okay, keep in mind, whenever you require to count something, you need to have a counter variable. Counter variable means a variable which is having starting value 0 and it is incremented by 1. So in this way loop will continue, and whenever this condition is get satisfied, it will be incremented by 1. So in this way it will be counting the value which is satisfying this if condition. Now the third part of the loop, to execute a loop we require 3 statements. This is initialization, this is condition, and now the third one, update. Then I plus equal to 1. Update part should be outside this if block. That's why I am writing in this indent. And after that I need to display the counted value. So after the completion of while loop means in this indent I am writing print x. So in this way you will count the value which are divisible by 5 in the range of two numbers, say a and b. Now we will apply this thing in some more complex question. Now another very important question, display factors of a number given by the user. Suppose user has given 12. So the factor of 12 are 1, 2, 3, 4, 6 and 12. These are the factor of a number. So you can find the factor of a number by continuous division starting from 1 till the number given by the user. Let us implement it in a program so that machine can find the factor. For that, first we need to read a number. So I am reading a number, int input, enter a number. So this is the number which is given by the user, for which we have to find the factor. Now to find the factor, we have to divide this number continuously from 1 to n. So we are writing the loop, we are initializing the loop index by 1 while the value of I is less than equal to n. Now I need to check whether this number n is divisible by I or not, because these are the value of I. So I am checking if n mod I equal to 0 means when this number get divisible by I, that means I will be the factor of that number. Means if 12 is divisible by 1, then 1 will be the factor. If 12 is divisible by 2, then 2 will be the factor. Likewise 12 is divisible by 3, then 3 will be the factor. 12 is divisible by 4, then 4 will be the factor. In this way, if n is divisible by I, then I will be the factor. I need to display the factor. To display the factor, I am writing print I. So this will display all the factors which are possible for the given value. And now to execute the loop for n number of times, we have to write the third part of the loop, that is update of the loop index. Because we have initialized it by 1, this is initialization, this is condition for the execution of the loop. Now this is the update of the loop index. We are incrementing the loop index by 1, like 1, 2, 3, 4, 5. So here we have incremented the loop index by 1. So in this way it will print all the factors of a given number. Now in the continuation of that, the last question of this concept, a very important question again. This question you will find in almost every exam from class 11 to the BTech. That is how you can check a number is prime or not. Prime numbers are those numbers which are having two factors. So if you want to check whether a number is prime or not, you have to count the factor. If the value of the count is 2, then the number is considered to be as prime. So let's start. First, we are reading a number, let us say int input, we are reading a number enter a number. Enter a number. This is the number which is required to be checked. It is a prime or not. So we have read the number, enter a number. Now to check whether this number is prime or not, first we need to count the factors of that number. So to count the factors of that number, we have to again apply this process that we have to check whether it is divisible by the number from 1 to n. So I am writing here I, let us say index number, it is 1. Now we have to continue the loop till while I is less than equal to n. After that we have to count whether this number is divisible by I or not. So if value of n mod I equal to 0, now here I have to count this, how many times this condition is satisfied. So in the previous question I told you, if you want to count something, then you need to have a counter. Counter means a variable which is having initial value 0 and it is get incremented by 1. So this is the counter. Loop will continue by incrementing the value. So I am incrementing the value by 1. So after the look at this here very carefully. In this question we are displaying the factor. That's why we have written print I. And in this question we have counted the factor. That's why we have put the counter over here. All the concepts are same. To count the variable we have used the counter variable. In this the value will be incremented. Now after the loop I am checking if the count is 2. Print it's a prime number. It's a prime number. And if the value of count is not 2, that is more than 2, I am printing the message it's not a prime number, that is a composite number, not prime number. So I have told you earlier in this question, if we want to check whether a number is prime or not, so to check a number is prime or not, first you need to count the factor. To count the factor we have used counter and we have executed a loop from 1 to n because we want to count the factor from 1 to n. Suppose let us take example. I am taking, let us say 7. 7 is the number which is given by the user. Now I want to check whether it is a prime or not. So according to this concept if condition, we are dividing this by I. Okay, means we are dividing n by I and the value of I is starting from 1 till n. N means 7. Means 7 is divisible by 1. Yes. Then the x will become 1. 7 is divisible by 2. No. 3 no. 4 no. 5 no. 6 no. 7 yes. Then again it will be incremented by 1. So it will become 2. So after the execution of the loop, the value of x will become 2. Means the value of count will become 2. And this condition will get satisfied. It will print the result. It's a prime number. Let us say another example. 8. It is n. Okay. Now again I am dividing it by 1. Yes, it is divisible. So value of x will become 1. Again 2. It will become 2. 3. No. 4. Yes. It will become 3. 5. No. 6. No. 7. No. 8. Yes. It will become 4. So the value of count will become 4. Now here when it will check the condition whether the value of counter is 2 or not. So in this situation value of counter has become 4. So this condition is not satisfied. So it will display the message it is not a prime number. Now I am modifying this answer to the perfection. Look at very carefully. We know that any number is not divisible after of its half its value. Means you cannot divide 100 by 51. You cannot divide 10 by 6. You cannot divide any number after half its value. So all the factors of a numbers are present from 1 to half of its value. So we can check the decision, we can take the decision by checking the factor till n by 2, because all the factors are present till n by 2. So if I checking the number, if I want to check whether a number is prime or not, then I need not to have the division, I need not to check the division till n number of times. We can check the division till n by 2. After n by 2, we will get the decision whether it is a prime or not. When we are dividing the number till n times, then the factors are 2, because 1 is the factor and n itself is a factor. But I have excluded n. So after excluding the n, now the prime numbers are those numbers which are having only one factor, that is 1. So I can modify here. Instead of 2, I am writing here. Now prime numbers are those numbers which are divisible by 1 and itself. We have excluded the itself number. So the prime numbers are those numbers which are divisible by 1, because any number can be divided only till it's half its value or less than of its half its value. So in this way, we have modified the answer till up to the perfection. This is the perfect answer for checking the prime number. Okay, so let's revise how you can check a number is prime or not. First, we have read a number. To check a prime number, we have to check the divisibility of that number from 1 to n by 2, because any number cannot be divided after n by 2. So to check the divisibility, we have started the loop from 1 till n by 2, and we are checking whether the number is divisible by the index or not. When the number is divisible, we have counted the value, because to count the value we have used the counter variable, which is having the initial value 0, and we have incremented the value by 1. And after the loop, if the value of the counter variable is 1, then the number is considered to be as prime, and if this condition is not satisfied, that the counter variable is not 1, then the number is not prime. Thank you.